Now, gang, I am willing to bet that if you didn't want to configure IPv4 addresses, you really don't want to have to statically configure IPv6 addresses. I mean, that's 128 bits of pain. So that's important to us, and it's of course going to be especially important if we are managing IPv6 related services that are going to function in a wireless environment. So I've got to supply IPv6 unique subnets for each of my wireless subnets that I'm managing for my access points. If they're going to be connecting with IPv6, all of that becomes necessary. Now, the configuration can be essentially the same. I can configure a DHCP v6 server, an independent server. We can manage that directly on the router if we want. It's a part of routing and layer 3 switches as well. So a lot of places we can configure this just like IPv4. It's important to know that there's two ways that we can run this, though. We can do stateful DHCP version 6, or we can do stateless DHCP version 6. Now, stateful DHCP version 6 basically multicasts out for a DHCP server, just like in IPv4 you'd broadcast out for one, and receives the opportunity to get an IP address. It says I'd like to have that IP address, and it gets it. So it goes through a special four-way handshake, very similar to IPv4. And when it does that, it's going to receive an IP address out of a pool of IP addresses defined on the DHCP v6 server, along with all the options, right? Here's your DNS server, your default gateway, your time server, whatever else we're providing. That is stateful. And remember that the DHCP version 6 server is going to keep track of all the MAC addresses that have been bound to all the IPv6 addresses from that pool. That's what we mean by stateful. There's a known state. This client is currently in the state of being associated with that address. It's in the database. The other option, stateless DHCP version 6, is significantly different, because in this configuration, our DHCP version 6 server is going to keep track of only the options in its pool. So it'll build a pool, but it's not a pool of addresses, it's just a pool of options, like your DNS server, your domain name, your time server, right? Those kinds of properties. Now, how is it able to get away with that and to allow clients to request this information from the DHCP server and go merrily on its way without having an IP address assigned to it? Well, the answer is the IP address is actually going to be assigned through the information provided by an IPv6 router. See, IPv6 routers are automatically going to perform something called a router advertisement of their IPv6 address. It'll say, here I am, I'm a router, and it's going to provide some significant information there. From that information that is being advertised through, by the way, the neighbor discovery protocol. So you'll see references to ND in the command line syntax for this. ND for neighbor discovery is associated with router advertisements. The client here is going to learn the IP address of this router. So for example, this router 2001:DB8, remember there's leading 0 we're not seeing, :0 represents 4 zeros, :20, :1. So remember, here's half of the IP address, and the last 64 bits, we just are using :: to get rid of the unused zeros and a value of 1. So this is just number 1 on the 2001:DB8:020 network. Remember that when we're talking about a network address, the first 3 chunks of an IPv6 address refer to the network. The 4th chunk is used to refer to the subnet, all right, when we use /64 addressing. So I said that to say this. All of this information is learned, and the client says, oh, now I know the network ID because it was just advertised to me, right? If I heard it, that announcement, then that must be what's local to me. And then it will append to that network ID a unique suffix that it will use for its own client portions, right? So it can't use :1. That's what the router is using. What could I use that could connect to :1? And what it will use is, by default, classically, it would be an EUI64, which means it'll take the 48-bit MAC address and convert it into a 64-bit block using a standardized convention, and that'll be unique, right? Because MAC addresses were already unique. Microsoft has moved away from that, by the way, as a standard because of security implications of knowing a device's MAC address just by reading its IPv6 address and performing layer 2 attacks against it. So they're using new conventions to come up with a unique IPv6 address based upon learning the routing advertisement and then coming up with a different suffix that will also be unique. But it's a 1-2 punch, all right? So the idea here is we learn the network information and I get a unique IP address, and hey, guess what? I know where my router is from those router advertisements. Everything else I need to learn, I will learn from a stateless pool of IP addresses provided by DHCP. Now, again, it's up to you to decide how you want to run this. If you like having the state of all of your devices, by all means, use a stateful configuration. You can run that way. But by default, again, this configuration actually is designed to give us a little better load balancing, allow us to get up and running and have a valid IP address on the network no matter what. Even if DHCP for some reason was offline, we'd still, as long as we have a router, we have a functioning routable IP address, which means if I can go to a device and see it, maybe I can remote manage it or do other things, even when DHCP is not running, as long as my router is running. And so that makes it fundamentally a stronger configuration and protocol. So remember, we'll need to configure the support for this across each of our interfaces, right, to be able to support all of these configurations. Key command to be aware of on your layer 3 switch or on your router. To enable support for this, you must issue the command IPv6 unicast routing. So let's say, for example, that we had a layer 3 switch here, right? And let's say that layer 3 switch, I'm configuring those virtual interfaces. I can configure virtual interfaces, no problem, but it will not route beyond IPv4 unless I issue this command, IPv6 unicast routing. Must be enabled to support this. Once I've done that, then I can issue other commands to follow along. So I might, for example, issue the command, right, interface VLAN 12, and then put in something like IPv6 address 2001:2 DB8 :0:20, if that was the VLAN that we were talking about, right, :1/64. That would be how I put that IP address on an IPv6 router or on a layer 3 switch's virtualized interface. And then I'd be able to receive those. If for some reason you have an interface and let's say you're using stateful DHCP and you want to turn off routing advertisements, then for that, you would issue the command IPv6 ND, that's for the neighbor discovery protocol, suppress-RA, suppress routing advertisements. So it's an important command to know. This is how you say, I don't want to support routing advertisements because I'm stateful and I don't want that noise on my network for no good reason advertising those devices.